Okay, a little primer on multiplying binomials. You are familiar with multiplication. We've been doing it for quite a while. If you had something like 4 by 3, you know, hopefully, that this is 4 groups of 3, and probably you're already there that that is 12, or 3 groups of 4, still 12. What we're going to do today, though, is we're going to model this with things like a rectangle. In this case, we might say that this is 4 by 3. And really what that means is that you have this top part is split into 4 equal 1 unit pieces, and this side part is split into 3 1 unit pieces, which eventually leads you to the idea that there are 12 individual squares here, and each of these squares would be a value of like 1 unit squared. Because it is a square, it's a unit, and there are 12 of them. So you'd eventually get that this is equal to 12. I know you're familiar with that, though. So let's make this a little bit more exciting. What if I asked you to do something like x plus 5 times x plus 3? I still have 2 things. This first part multiplied by this second part. I can model that still using a rectangle. And in this case, what that might look like is this top part, I would say this is x plus 5, and this side would be x plus 3. You can still model this whole thing. If you start isolating each of these rectangles, this first rectangle is just going to have a value of x squared because it is x times x. This second rectangle over here would give me a value of 5x because I have 5 multiplied by x. Down here, we'd have a value of 3x. Oops, wrong thing, sorry. And then over here, we'd end up getting 3 times 5, which is the same as 15. And then if you wanted the total area, just like up here to get the total area, we said 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 3 groups of 4, which is 12. You need all 4 of these pieces of area together. So we could say that this was x squared, check, plus 5x, check, plus 3x, check, plus 15. And this right here is a perfectly reasonable way to describe the area of the rectangle created by this multiplication problem. One thing you might note is that since I have 5x here and 3x here, if we can just recall real briefly that 5x is the same as 5 x's being added together, and 3x is just 3 x's added together. Really what we have is we have 5 groups of x plus 3 groups of x. That would get us a total of 8 groups of x. And we could simplify this to just have 3 terms, x squared, 8x, and 15. And this is absolutely a correct, good way of describing the area of this. So the things that I have just highlighted in white here and here mean the same thing. Our goal today is to kind of practice this a little bit. Please let me know if you need any help.